Welcome to today's lecture. Today I will discuss about impulse properties of impulse function. So this impulse function is one of the most important signals. So we need to give little bit more detail. We need to take more on this properties. First is del of 0 equal to infinity. You know what is del of 0? At time t equal to 0, amplitude is infinity. At time t equal to 0, its amplitude is infinite. It is going upwards. So infinite amplitude. At time t equal to 0, what is the next property? Del of t equal to 0 for t not equal to 0. That means at t equal to 0, it has maximum amplitude. Above 0, below 0, that is t not equal to 0. On those timing values, amplitude is 0. Another important property, minus infinity to plus infinity del of t dt equal to 1. That means if you integrate from minus infinity to plus infinity this function, you will get to 1 value. Del of minus t equal to del of t. That means if you take a mirror image of this, you put a mirror in this y-axis and you check the image on the mirror, you will get the same image only. That is, if you take mirror image of this signal, you will get the same signal. That is del of minus t equal to del of t only. Another important property is sampling property. X of t into del of t minus t naught equal to x of t naught del of t minus t naught. That means if a function given like this, instead of t you have to put t naught, that is x of t naught. This t naught should come here. Take an example, 2t plus 1 into del of t minus 3. What is this? Is look like this only, instead of x of t they are writing 2t plus 3. So here t naught is 3, you put 3 here. So 2 into 3 plus 1, that is 7 into del of t minus 3, that is 7 into del of t minus 3 is the answer. Another one is shifting property. What is shifting property? Integral t1 to t2 x of t into del of t minus t naught equal to x of t naught. That is from t1 t naught greater than t1 less than t2 and 0 elsewhere. That means if a question like this, you have to check this t naught. Check that this t naught should lies in between these two. Okay, check the value of t naught and check whether it is lies in between t1 and t2. If it is like that, then that t naught should be, this t should be replaced by this t naught. Otherwise, if this value is not lying in between these two ranges, then you can put entire value as 0. Result is 0. So look at here example, integral 1 to 3t into del of t minus 5. What is x of t here? X of t here it is 3t. Del of t minus t naught here it is del of t minus 5. What is t naught here? 5. Check that 5 values lies between 1 and 3. Is it? No. 5 is not in the range of 1 and 3. 5 is above 3 only. Okay. So this condition is not satisfied. That means elsewhere you should put answer is 0. So if you evaluate this directly, you don't want to do any integration process, directly you can put 0 here. This is the importance of this property. With this property, we can solve the function very easily. We can solve the question very easily without doing any integration or any mathematical operation. You can simply put the answer with the help of this property. Another property is del of alpha t equal to 1 by mod alpha del of t. Suppose del of 2t like that, then you can put 1 by 2 into del of t. Both are right. Now u of t, step function. You know what is step function. If you integrate impulse function from minus infinity to plus minus infinity to t, you will get step function. That means if you integrate this, see here we have property minus infinity to plus infinity del of t dt means it is 1. That means 1 is nothing but, for 1 means for all the time value amplitude is 1. That is, it is like this. For all the time value amplitude is like this. That means it is a step signal only, which have both positive and negative. So here how to write this? If you integrate the step signal, from minus infinity to t, you will get u of t. So step, if you integrate impulse, you will get step. Okay. So how to take the reverse? If you want, in the question they are given step function, you need to find out the impulse function. How to do? Just reverse this. Integrate, differentiate the step, you will get the del of t. Okay. So del of t, that means impulse function is the differential of step. Okay. If the impulse function is given, they are asked to find out step, then you need to integrate. Okay, and they are giving step, and if you are asked to find out impulse, at that time what you have to do, just a reverse of this. That means integral become differential here. You just differentiate the step, you will get the impulse. So if you integrate this impulse, you will get step. If you differentiate the step, you will get impulse. Similarly, ramp. If you differentiate ramp, you will get impulse. So if you integrate the step, you will get a ramp. Okay, just a reverse. How to find out ramp signal r of t? You just integrate the step signal, you will get ramp. Here, you differentiate the ramp, you will get step. Next is basic signal operations. Okay, what are the basic signal operation? First one is take this signal. This is my signal, and it is represented by x of t. My signal is represented by x of t, and it is varying from -1 to 2. Okay, -1 its amplitude is 0. At 0 its amplitude is 1. At time 2, t equal to 2, amplitude is 3. Look at here, x of t. This signal is defined mathematically like this: x of t equal to t plus 1 for -1 to 2. T lies between -1 to 2 and 0 elsewhere. Is it correct? See, for -1 to 2, a signal exists there. Below 1 and above 2, no signal, right? That means from -1 to 2 only it is having value. Otherwise, all other timing values, amplitude is 0 only. Now, how to write the amplitude here? So, -1 t 2. So, t lies between -1 and 2. So, what is the value at -1? How to write? X of t is t plus 1. Here it is given like that. So, you put first value. Instead of t, you put t value, you put a -1 here. So, -1 plus 1. You put t value, you put -1. So, -1, you put -1 plus 1, 0. That's why amplitude at -1 amplitude is 0. Now, how to find out the amplitude at 2? That means at time t equal to 2, you put 2 here in time t. Instead of in the t value, you put t equal to 2. So 2 plus 1, 3. That means amplitude is 3. Okay, like this we are drawing. Okay, if this function is given and they are asked to draw the signal, how to draw? How you will draw? You just the range value. You first check the range value. Oh, this function anomaly exists in between these two ranges only. That I understood. Then now check the another condition. What is the amplitude? Yeah, what is the amplitude? How to find out the amplitude? So first you give t value as -1, then you will get an amplitude. You take t value as +2, then you will get an amplitude. Then you complete that. Okay, how to draw this? It is like that. Now x of t is given. They are asked to find out x of -t. This is x of t. How to find out x of -t? So, you know x of t is t plus 1. So, what is x of -t? X of t is t plus 1. In the question they are given. And they are asked to find out x of -t. See here, x of t is t plus 1. X of t, here t become -t. So, wherever t exists, you change all the t with the -t. In the question they are given x of -t. So, to find out x of -t in the question, wherever t exists, you change that t value with this -t. So, -t plus 1. Okay, see, this is our question. X of t is t plus 1. This is the value. And they are asked to find out x of -t. So, this t become -t. What you have to do? You have to change all t values to -t. So this t become -t, this t become -t. That's why I wrote like this. -t plus 1 equal to -1 minus t 2. Now change the value. -1 become plus. I'm changing in the entire values. -1 become plus, less than become greater than, -t become t, less than become greater than, +2 become -2. So t values lies between 2 and 1. This can be represented as -2 greater than t less than 1. So I am drawing the signal like that, -1, 0, 2. So my signal is from my signal is from -2 to 1. This is x of t only. X of -2 we are drawing, -2 to 1. And how to draw the amplitude? You check amplitude. To find out amplitude, you put -2 here. -2 into minus plus 2 plus 2 plus 1 plus 3. So at -2 amplitude is +3. What is the amplitude at t equal to 1? You put t equal to 1 here. So -1 plus 1 0. So at t equal to 1 amplitude is 0. So we draw like this. Okay. So the remaining we will discuss in next class.